All right, so this is going to be our first lecture for intermediate algebra. At least that's what I'm planning on. And we're going to start doing section P1, but before we do section P1, let's get I should blab just a little bit. First of all, this calculator that I have displayed on the screen is the ultimate best calculator for our class. I can't think of a better calculator for our class, and you should absolutely plunk down the $18 or $20 that it takes to get this calculator. I own the $100 graphing calculators, and they're nowhere as good as this calculator for our class. So absolutely you want to get it. If they sell this at Walmart, Office Max, you can get it on Amazon. I'm sure you can get it all over online. If you went to like Walmart or Office Max, Staples, you might see a calculator that looks like this calculator, but it's black in color. And I think that's the number of that calculator. So our calculator is silver, this calculator is black. The black version, or the 300 version, it's cheaper. It might be $2, $4, $6 cheaper, but there's a couple things that this calculator can't do that the more expensive one can do. You should get that calculator. Boy, it might be nice to have it even before you start doing this lecture, because I'm probably going to wind up using the calculator today. And on top of calculator, absolutely guaranteed, in about 90% of the videos you're going to watch this semester, somewheres I'm going to make a mistake. I'm going to say one thing and write another that's completely wrong, or I'm just going to say the wrong thing. It's just going to happen. It's inevitable. If you see a mistake and you understand the mistake and you know how to fix it, that's a really great, fantastic thing. If you think you see a mistake and you don't understand how to fix it, or you want to point it out to me, shoot me an email. I'll take a look at my mistake, and if I need to, I'll re-record that chunk of the video. And my email address is john.grimma@gccaz.edu. Now I'm going to get started. I'm having some technology issues this morning. I think as my monitor on my computer shuts off, it stops my video, which made me restart recording a video and then restart now. So I'm going to try to keep that from happening. Anyways, we're going to do section P1 to start. Generally, as I do a video, I lecture on some theory, and as I'm lecturing, I do all the even problems in a section. Usually I ask you to do all the odd numbered problems in a section. It's always a super great idea to do all the odd numbered problems in any section that recover, specifically because it'll help you understand the material for the test, for later in the semester, and probably more importantly for your next class. Intermediate algebra is kind of the foundation of most higher math. Most of you, if you have another math course, it's going to be college algebra. And in order to do well in college algebra, you really need to understand intermediate algebra really well. And if you kind of don't do everything, you'll probably miss some of the subtleties that are buried in some of the problems as you skip the problems. And that may come back to haunt you. So your understanding won't be as good as it should, and you might pay the price for that. Maybe not in this class, but probably in the future. So let me just jump into doing some problems right now. So in section P1, it starts off, and the first 14 problems all have the same instructions. The instructions ask me to start off and identify. The word identify kind of clues to me that there isn't any algebra to do. The algebra is identifying pieces, and the pieces I'm supposed to identify for each problem, there are three: a base, an exponent, and a coefficient. So the instructions ask me to identify, so no algebra, the base, the exponent, and the coefficient in the following expression. An expression is just simply a problem without an equal sign. If I look at the problems on the screen right now, I don't see a single equal sign, so these are all expressions. It's in terms of definitions, I don't really ask definitions on tests, and I probably don't do the best job writing out formal definitions. You just have to understand the concepts. You don't physically have to know how to define a word. But anyways, the easiest of the three items that I need to identify between the base, the exponent, and the coefficient, the easiest one to identify is the exponent because it's going to be superscripted. It's going to be raised higher. And in this section, each of the exponents is a whole number, or I guess it's a natural number, 1, 2, 3, 4, 5, 6, 7, 8, 9. And an exponent, if it's a natural number, 1, 2, 3, 4, 5, 6, 7, 8, 9, up to infinity, it is a shorthand for repeated multiplication. And it's a shorthand for repeated multiplication of the base. In problem 2, as I go to identify the three pieces, the one that was easiest for me to identify is the exponent, and that's the superscripted part 4. You may be able to answer the other questions, but before I jump into saying the answer to the other pieces, what the base is for problem 2 and what the coefficient for problem 2, I'm going to rewrite the problem without the exponent, and that might make it more clear the difference between the base and the coefficient. The exponent, when it's a whole number or a natural number like 4, stands for repeated multiplication, and it only stands for repeated multiplication of the number or the letter that it's directly attached to. And in problem 2, the 4 is only directly attached to the y. It's not directly attached to the 7. So if I wanted to write 2 without the exponent, I'd write 1, 7, and 4 y's. This y to the 4th part of number 2 means y times itself 4 times. You notice when I rewrote this problem without the exponent, I don't have any signs between the numbers and the variables, or the numbers and the letters. Variables and letters I can use interchangeably. When numbers or letters are written next to each other, there's an implied time sign between them. So this is 7 times y times y times y times y. It's important to understand, but not important in terms of answering the question. To answer the question, the base is the number or variable / letter that the exponent applies to. The base is just going to be the y, because that's the term that would be written repeatedly if I wrote the problem without the exponent. The coefficient is a number, or could actually be a variable, that's multiplied by the base. And in this particular problem, there isn't a time sign written between the 7 and the y to the 4th, but it's an implied. If there's a number or a letter to the left of a base exponent combination, that number is going to be the coefficient. It has to be attached by multiplication. If there was an addition or subtraction sign between the 7 and the y to the 4th, it wouldn't be the coefficient. But in this case, the number that's multiplied by the base is the coefficient. In this case, it would be 7. You should be able to do problem 1. I don't want you to write base, exponent, coefficient for every single problem. Probably in your answer, you shouldn't just write down the 3 answers. You should write something so I could figure out which each stands for. And in problem 1, if you were doing this, I would probably write B when I want to write the base instead of writing the word base. E when I try to identify the exponent, and C for the coefficient, rather than writing the whole words. Since it takes a second, you can pause the video and write the answer, or I'll write the answer down here because it's so easy. Exponent's the superscripted part. It's the 3. The exponent in problem 1 only applies to the x. If I wrote problem 1 without the exponent, it would be 5 times x times x times x. And the coefficient is the 5. It might be nice in my answer if I said base equals x, exponent equals 3, coefficient equals 5. But equal signs, maybe they look nice, but they're not really necessary. So 3 and 4, which we kind of have coming up next, are essentially the same. I'm just going to write the answer down without a lot of explanation. The order that you write your answers in doesn't matter. If you wrote the coefficient first, the exponent second, and the base third, it doesn't matter to me. but I'm going to do the answer quickly. And I like identifying the exponent first. It's super easy for me to find. It's the superscripted part. In this case, it's the 2. And again, the 2, or the exponent, only applies to the number or letter that it's directly attached to. And in problem 4, the 2 is attached to the z. When I write my z's, I put lines through them because sometimes my z's and 2's start to look the same. So always I'll write a line through a z. So in this problem 4, my base is going to be z, and then the coefficient is the number that's preceding multiplied by the base, and it's going to be 9. Your problem 3 should work the same way. Problem 5, if you jumped ahead, which would be a beautiful thing if you jumped ahead, anytime I start doing a group of problems, if after I do 1 or 2 in that grouping, in this case 1 or 2 of the ones between 1 and 14, if you could do the rest without me explaining them, absolutely do the work, try to blow through the answers, and then just jump ahead in the video. You can absolutely always, and you probably should, check your answers. So because you found these problems hopefully on my website, if you went to my website and under chapter P, if you went under the problems link, I think there's a link that says problems and answers. You should be able to check the answer for every problem that you have. Maybe in a later video I'll pull out my tablet if I can get it connected to the internet and show you exactly where the answers are. I'm going to do kind of a generic video explaining how the class works, and I might have already shown this, but anyways, let me just keep plodding along because my videos get so long. In problem 6, there's a negative that precedes the z to the 8th, and that negative, it really is a shorthand, and it's a shorthand for a -1. So problem 6, it's shorthand, which is a common shorthand. It means -1 times z to the 8th. That negative stands for a -1. And in this problem, I only see kind of 2 pieces. That negative almost looks like it's part of the base, but it's not. It's actually part of the coefficient. And if I went to answer number 6, the base, the exponent, and the coefficient should be not disgusting to find after I've rewritten this. The exponent's the superscripted part. It's the 8. The base only applies, it's the number or letter that the exponent applies to, and the exponent only applies to the z. If I wanted to rewrite problem 6 without an exponent, it would be a single -1 followed by 8 z's, no space, no signs between the z's unless I want to write a time sign, but this is an implied -1 times z times 8 different z's. I could have written this problem without the exponent with just a single negative sign followed by 8 z's. This is a super evil trick. Comes up, and calculus students miss it all the time. If they were going to rewrite this, they might write 8 negative z's, 8 negatives and 8 z's, and that would be wrong. The coefficient in problem 6 is the -1, and you only get one of the coefficients. This is an evil trick, but it's a trick that comes up a lot that you should be familiar with. Last problem on this sheet, then I'll flip to another sheet. If I look at problem 8, I don't see a superscripted part, I don't see an exponent, and more often than not, if there's a component that's missing, that component's an implied 1, and that's exactly the case in number 8. There isn't an exponent written, so there's an implied exponent of 1. It's not necessarily, if we had to write it every time, it would just take so much more time to write it. So we'll just say if an exponent isn't written, it's assumed 1. Generally, if something isn't written, it's assumed to be 1. Here, the number wasn't written after the negative sign, was assumed to be 1. If I went to answer number 8, it's base, exponent, coefficient. The exponent is the superscripted part. I inserted it, it's a 1. The base is what the exponent applies to, and it applies only to the y. The coefficient is the number that's multiplied by the base. In this case, it's -5. I couldn't really write number 8 with repeated multiplication because there's only an exponent of 1. So this is probably as nice as I could write number 8. So you should be able to do number 11, and we'll move on to another sheet. And another slightly trickier sheet. So if I look at problem 10, which is, you can't see it, if I looked at problem 10, the instructions are the same. This is still part of numbers 1 through 14. Asks me to identify the base, the exponent, and the coefficient. In problem 10, it's the first problem in this grouping of problems that has a parentheses, and it might make problems a little bit harder, but it won't make the exponent identification harder. In this case, the exponent is still the number 3. When I have a parentheses and there's an exponent outside the parentheses, that entire contents of the entire parentheses, or the insides of the parentheses, is the base. It would be the thing that would be written multiple times if I was going to write the problem with repeated multiplication. And in problem 10, if I want to write this with repeated multiplication, I'd get 3 of the parentheses 8y plus 1. So it'd be 15 times 8y plus 1 times 8y plus 1 times 8y plus 1. The base is more complicated when there's a parentheses. The base, if there's an exponent outside of a parentheses, the base is usually the entire contents of that parentheses. And I usually write the base without the parentheses if I'm just saying what the base is. But if I'm writing the problem without the exponent and using the repeated multiplication, then I keep the parentheses. But if in your answer you wrote the base is 8y plus 1 and you left it in a parentheses, it doesn't matter. It turns out that these two expressions, problems without equal signs, are equal to each other. When you have a parentheses enclosing an expression, if there isn't a coefficient preceding the parentheses or an exponent outside the parentheses, then you can just drop the parentheses and the parentheses version and the non-parentheses versions are equal to each other. Last part of 15 is the coefficient. The coefficient is the number that's multiplied, not added or subtracted, directly to the left of the base, and the coefficient here is 15. So you should be able to do problem 9. It's the same. You might be able to do problems 11 and 13. If you can, do them. And I think I'm going to pause the video here. It's getting to be 20 minutes long. And the next group of problems is probably going to be 40 minutes. And I don't want this video to be an hour. If you can't do 11, let me do 12. I'm going to rewrite 12 so that you can see the coefficient. A negative sign preceding a base is always implied to be a -1 coefficient. And so that's how I would rewrite problem 12 so the coefficient is more clear. And if I go to write my answer, base, exponent, coefficient, the exponent's the superscripted part. That's easy. It's the 7. The base, when there's a parentheses and an exponent outside the parentheses, the base is the entire contents of that parentheses. You don't have to write the parentheses in your answer when you identify the base, but you could. It's not wrong. But if you have a parentheses and it doesn't have a coefficient to the left of it, it doesn't have an exponent outside of it, then that expression is equal to the version without the parentheses. And then the last part of this is that evil trick. If there's a negative written preceding a base, that's an implied coefficient of -1. I'm not going to take the time to rewrite this without the exponent, just because I don't think you really need to see it. Last problems 13 and 14. I don't see everything I need. I see the exponent. The exponent applies to this entire parenthesis, so the base is 4x plus 1. And because there isn't a number written to the left of that parentheses, and I kind of need to imagine one, that there's an implied 1 that's written there. So if I was doing problem 14, I have to think of it like this. And when I go to write my answer for base, exponent, and coefficient, I need to think of that one even if I don't write it in. So in this problem, the superscripted part is the 7. That's the exponent. The base is the 4x plus 1. That's what the exponent applies to. And I can write the base with or without a parentheses. It doesn't matter. And then the coefficient is 1. So I'll stop the video now. If I wanted to rewrite problem 14, which I don't, if I wanted to write problem 14 without the exponent, then I would need to have a string of 8 4x plus 1's in a parentheses. I don't think I can get those all fitted here, but the proper way to write 14, if I was asked to write it without a parentheses, would be a string of 4x plus 1, 7 of them. I wouldn't really need to write the coefficient because it would be implied, and I wouldn't want to simplify this. This would be a disaster to simplify. If you had to simplify the 4x plus 1 to the 7th power, it would you'd either have to do a really, really painful string of multiplications, which we'll learn how to do a little bit later in this chapter, or you'll have to do something using something called Pascal's triangle that some of you might have had in high school. So I'm going to stop the video now and make a part 2 and maybe a part 3 to get through this section. So we're not done with the section, but we're done with the video. This is the end of part 1. There's going to be a part 2 coming up.